let us discuss today the chapter what we have next to the current electricity part and electromagnetism part, that is electromagnetic induction. In fact, this particular topic comes under electromagnetics. That's a major chapter what we have. And electromagnetic induction is one such a chapter from which every year he is giving few applications in the final examination of JEE. So one should not leave this topic under any circumstances, and one should be perfectly thorough with this chapter so that to score the best out of the lot as far as the questions given from this particular chapter they are concerned. So let me just start with the very first problem, what has been given this way. A closed coil with a resistance R is placed in a magnetic field. The flux linked with the coil is given phi. If the magnetic field is suddenly reversed in direction, the charge that flows through the coil will be how much? So the concept we people should understand first of all is electromagnetic induction. When we discuss, the very first equation we need to know is the induced EMF, which of course that is observed in the system due to magnetic induction, that is equal to the rate of change of magnetic flux in the system. That of course we used to write E is equal to d phi by dt. That's a basic equation. But according to Lenz's law, when we give direction to it, when we observe the direction of induced EMF over there, according to the law of conservation of energy, we used to get a negative sign before. So E is equal to minus d phi by dt. That is the formula for induced EMF. So when we talk about E is equal to minus d phi by dt, this E being induced EMF can now be written as IR in terms of Ohm's law. This I again can be rewritten as dq by dt into R. Out of that, what is this value of charge he is asking you? But one thing you should understand, directly if you look at the charge Q can be directly calculated by taking phi by R. There is nothing in that. But observe this wording carefully, it is d phi. That is the change in magnetic flux. That also he is very clearly mentioning in the problem that suddenly the magnetic field is reversed. When you take the initial value of magnetic flux as phi, when it is being reversed, it should be considered as minus phi. When you take the difference of those two, it becomes now 2 phi. So what will now be the value of charge over here? It's twice phi by the value of R. So that is the concept what you need to understand. I once again repeat, when we talk about charge, no doubt it is phi over R. Phi is magnetic flux and R being the resistance over there. But one should understand in this particular case, when the magnetic field is being reversed, if you take initial magnetic induction over there or magnetic flux over there I am talking about, that as positive, then automatically when it is being reversed, it should now be taken as negative. Then what would be the difference in the magnetic flux? It's minus phi, minus phi. That is actually phi 2 minus phi 1, which now becomes minus phi. That's the final flux minus phi. That is the initial flux. So it now becomes minus 2 phi. Minus 2 phi by R. But already there is a negative sign over here. That minus of minus, that now becomes plus. So automatically you will be getting 2 phi by R. But observe carefully from the same problem. Suppose the magnetic field has not been reversed. The magnetic field has not been reversed. Then our answer would have been phi by R simply. Since it has been reversed, you need to take twice the value. Why twice? The reverse direction, we used to take the flux with a negative sign. That's important most aspect one should understand. So the difference that time will be minus phi, which now becomes minus 2 phi. That minus 2 phi in place of this d phi, if I write, that minus of minus becomes plus. So automatically plus 2 phi by R, that now becomes the charge over there. So the options, if you look at, first option is phi by 2R. Second option is phi by R. In fact, that would have been our answer had the magnetic field has not been reversed. But in this particular case, since it has been reversed, B is not the correct answer for us. What is the next option? C. That is 2 phi by R. And fourth one automatically be 0. 0 is not going to be the correct answer. Whatever we have calculated here, this value now is in coincidence with the third option over here. Therefore, we can say the answer for this particular question number 1 is C. So reversing the magnetic field, that matters. That is one of the excellent concepts what we people used to come across in this particular chapter. In most of the problems, that fellow used to say that the magnetic field is reversed or it has been rotated by 180 degrees. That 180 degrees is nothing other than it has been reversed indirectly or directly, whatever you call it. So that is the way we people have to tackle this type of a model question. That is problem number 1 what we have. Let us just switch over to the second problem in the same order. A coil of 1200 turns having mean area of 500 centimeter square is held perpendicular to a uniform magnetic field of induction 4 into 10 power minus 4 Tesla. One thing first of all we should understand here after reading the first sentence of this problem, that coil is placed at right angles. Then only you can all understand the flux that is passing through the coil is maximum. Suppose if the total coil is parallel to the direction of the field, if the magnetic field is just from left to right, if the coil is parallel to it, then you will not find the value of flux passing through that. That time the change in flux or flux, whatever you call, that will be minimum and its value will be 0. That anyhow we have studied. Same concept he is giving very clearly in the wording, that the coil is placed perpendicular to the direction of the magnetic field. What is the value of magnetic field of induction given over there? You see, it's 4 into 10 power minus 4 Tesla. Now what is the question he is asking? The resistance of the coil is 20 ohm. Fine. When the coil is rotated through 180 degrees in the field in 0.1 seconds. That is the concept. When the coil is rotated through 180 degrees, it is as well equivalent to reversing the coil opposite to the direction of its original direction. Simply reversing, that is nothing other than rotating it by 180 degrees. In what time? 0.1 second, that has been given. Then the average electric current induced is how much? Current induced in the circuit or in that coil we just want. So 4 options once again he has given. The first option is 12 milliampere. Second option is 24 milliampere. and third option being 36 milliampere, and fourth option is 6 milliampere. The correct option for this one is no doubt B. That of course we are going to calculate right now. Coil of 1200 turns. He has given you the number of turns over there, 500 centimeter square area. That is A, which is area of that entire coil that has been given. And magnetic induction field is given, time given, and he said it has been reversed in its direction, rotated by 180 degrees. These are the points what have been covered in the problem. So let us once again check this way. The induced EMF no doubt is minus d phi by dt. That if I write in general, I can write NBA by T like. You can understand N being the number of turns over here. B is the magnetic induction in which the coil has been suspended, and A is the area of the coil. Fine. By T. But again he is giving in this particular case that the coil has been rotated by 180 degrees. Rotated by 180 degrees means immediately you should get your mind that this d phi now becomes twice phi. That is minus phi, again minus 2 phi. Minus of minus becoming plus, no doubt. So this now to be taken as twice NBA by T. That is actually the value of EMF. But he is not asking you the value of EMF in this problem. What is current? In fact, this EMF, I can write it as IR according to Ohm's law. So we now can rewrite the same equation for current this way, twice NBA by T into R. Truly speaking, we people used to write here NBA either cos theta or sin theta depending on the angle what we people are taking up. When we consider the normal is making an angle theta, then of course we people used to say that it should be taken in terms of cos. If the coil is making, or the plane of the coil is making an angle theta, plane is making an angle theta in the sense if plane is perpendicular, flux is maximum. That is the condition what we people have to understand. So the normal is making 0 degrees there. Then we people used to say cos 0 now becoming 1. So that way either we have to write here NBA cos theta or NBA sin theta depending on the angle what we people are considering over there. Is the plane of the coil making an angle theta or normal is making an angle theta? Accordingly we used to write. But in this particular problem, very clearly in the problem itself, he has given us that the coil is perpendicular. Coil is perpendicular means normal is making an angle 0 with the field. That time we take cos theta. Cos 0 becomes 1. So that we need not write directly. I am putting the step here. So every value out of it we know. Now let us write the numbers what have been given there. Number of turns over here will be is given as 1200 turns he has given very clearly. And magnetic induction is given as 4 into 10 power minus 4 Tesla. The value of area of the coil also has been given, but in centimeter square it has been provided. That's 500 centimeter square, which I can write directly 10 power minus 4 is the multiplication factor to convert it into meter square as such. This over the time in which that coil has been rotated by 180 degrees. That has been given 0.1 second. Better write 10 power minus 1. And what is the the value of resistance that has been provided? It's 20 ohm, very clearly as mentioned. There is coil of resistance 20 ohm like he gave. So if you just look at 1, 2, 3, 4 zeros, you can cut with this. and straight away 4 times 5 now becomes 20. And of course you will be getting here, this one goes minus 3 times. So 24 into 10 power minus 3 ampere. In other words, 24 milliampere we can write. But be a little careful about the same condition what we have discussed even in the previous problem. The coil has been rotated by 180 degrees. It has been very, very clearly mentioned in the problem. In fact, while reading the problem only, it is better you should underline that 180 degrees like. Otherwise what happens? You never go for twice this value. When you are not going twice this value, you will be getting 12 milliampere. And see the very first option what has been given, that is 12 milliampere. So it will be trapped there. So the moment it is reversed by 180 degrees, 5 will be doubled. That is the point one should understand from this problem. Then automatically you will come across 24 milliampere. This is tallied with the second option out of the 4 options given in the problem. So what is that one here? The answer for this one now is going to be simply B now. So this is the method we people used to adopt. And this particular formula is common. Truly you can write NBA cos theta and then you make that cos theta 1 and you calculate this, whatever be the methodology you want to follow. But ultimate result must be like this. This is problem number 2 what we are having here. So when you just check the next number, that's problem 3. It is a problem which is based on motional EMF. When a particular body like a uniform rod is just moving right across a magnetic field with a constant speed or making an angle theta with the direction of the magnetic field with a constant speed, then how can we calculate the induced EMF across the ends of that rod? It is in fact based on that concept they have just given us this third problem. If I read out this one, you will be able to understand what exactly he is asking for and how to take the formula for that. A train is moving towards north. Direction is very important here. A train is moving towards north with a speed of 180 km per hour. If the vertical component of Earth's magnetic field is 2 into 10 power minus 5 Tesla, the EMF induced in the axle of the train of length 1.5 meter is how much? That axle itself is the one which is moving right across the vertical component of Earth's magnetic field. And what are the values he has provided? First option is given 1.5 millivolt. Second option is given 15 millivolt. Third option is 54 millivolt. And fourth option 5.4 millivolt as such. And in true sense, the correct answer for this one is 1.5 millivolt, which is the very first option for us. But what exactly the concept here? Train is moving towards north, he is talking. Actually speaking, Earth's magnetic field will be taken from south to north like. When we take in that direction, when train is moving towards north, the motion of that train is parallel to the direction of the magnetic field due to Earth. When they are parallel, there will not be any amount of induced EMF you can observe. Reason, there will be no change in magnetic flux with respect to time. That in other words, there will be no rate of change of magnetic flux in that case. That is why he gave an excellent concept there. Vertical component of Earth's magnetic field is given. When vertical component of magnetic field of Earth is given, when this train is moving towards north, you can understand straight away that this train is moving perpendicular to the magnetic field. So definitely there is a possibility, there is a chance for that magnetic flux to vary with respect to the time. That in the sense, rate of change of magnetic flux is going to be possible there. Why I am repeating this particular point, you can understand. By any chance, in the same problem, if he gives, instead of vertical component, horizontal component of magnetic field is given, then in simply speaking, there is no need for it to do the problem. Without attempting it, you can put the answer 0 for it. There will be no magnetic flux variation with respect to time. There will be no induced EMF. There will be no current induced, whatnot. Everything will be 0 straight away. But here, since the motion of the train and the magnetic field of Earth, what has been given over there, are mutually perpendicular to each other, you will be finding maximum possible variation of magnetic flux with respect to time. So that is the concept we have to understand first of all. And of course, what is this question? 1.5 meter is the length of the axle given. Across that axle, that means across the ends of that axle, what is the induced EMF, he is asking. So we generally take this one as motional EMF in this case, because the body is in motion. Due to that movement, we people are observing some induced EMF across the terminals of that particular body. In this case, it is the axle of the train. So what is this motional EMF in this particular case? It is BLV. What is this B here? It is the vertical component of Earth's magnetic field. What is this L here? Length of that axle of the train, across which the induced EMF we people are just going to calculate. In addition to that, this V gives you the velocity with which the train is traveling due north. In this particular example, it has been given very clearly 180 km per hour. So directly it will be 50 meter per second, straight away we can take. But by any chance, if the train is moving, making an angle theta with the direction of north, making an angle theta with the direction of the axle, which is along east and west directions, then we used to consider here either V sin theta or V cos theta, depending on how we people are considering that angle theta there. If you take with respect to the north the angle theta, then we have to write in terms of cos theta there. If you consider theta with respect to east-west direction, then we people is to take that angle as a sin theta over there, that component. But in this particular case, no need for us to take any of the components. Reason being known better to you, is very clearly mentioned in the problem that the train is moving due north and its vertical component of Earth is given. In addition to that, across the ends of the axle, he is asking you to calculate the value of induced EMF. So straight away calculate what is the value of vertical component given. You see that 2 into 10 to the power minus 5 Tesla. Length of the axle is given simply 1.5 meter. Velocity being 180 kilometer per hour, which now that into 5 by 18, we know that 150 meter per second as such. So straight away we can write 50 over here. Now in fact we can cut this decimal with this 0, and 5 into 15, it's going to be 75 into 2. It's 150 into 10 power minus 5. In fact, it is in volt. That itself is the answer in fact. But according to the options given, we just have to convert that. This is 15 into 10 power minus 4 volt. Or you can even write the same 1.5 millivolt as such. So when you look at this 1.5 millivolt, the options given over there, if you look at, the first option is tallying with this value obtained. So automatically we can write the answer for this particular problem as A. So only point in this you should understand is whether the motion of the train is perpendicular to the magnetic field or not. If not perpendicular, it should make some other angle other than 0 or 180. Then only you will be finding the induced EMF, otherwise not. As I have already told you, if he gives in this problem horizontal component of Earth's magnetic field by any chance, absolutely no need for you to attempt the problem, like you need not calculate anything. The moment it is given a horizontal component, you can directly come to a conclusion that there is no induced EMF possible. So answer will be 0. Across the axle, that should be the condition. Remember that. So for this, the correct answer is A. Remember that. This problem number 3. Let us check the next number, which in fact has been asked in one of the IIT-JEE papers. A coil having n turns and resistance capital R ohm is connected with a galvanometer of resistance 4R. This combination is moved in time t seconds from a magnetic field W1 Weber to another field W2 Weber. The induced current in the circuit is how much? That is the concept. So initial magnetic field he is giving you, that is in fact W1 Weber he gave, and W2 Weber he gave. That is okay. The second one, this is problem 4. W2 Weber is going to be the final magnetic field. If you just look at what are the other values he has mentioned, you see there are n turns in that. R is the resistance of that particular body. There is a coil what he is giving us. It is now connected in series to a galvanometer. Very clearly he is mentioning that its resistance is given as 4R. So automatically when both are in series, 5R will be the effective resistance. So first thing you should understand is that, so effective resistance should be 5R. In addition, what is he talking? In t seconds it has been moved from this field to this field. Then what is induced current? That is the question. Okay, as usual go ahead with induced EMF first. Minus d phi by dt. But of course we can write this one as IR. Only point you should understand here is, what is current from this now? It is 1 by R into d phi by dt. What is this R now to be called? R effective value. Now, just check this one. D phi actually will have B into A. In fact, d phi is equal to B dot A, BA cos theta, we people used to write. But in this particular problem that year in IIT-JEE paper, he did not mention the value of area there. So what you should understand in his opinion, this W1 and W2, these two values themselves are directly the values of phi values only. Actually phi should be written B into A. If I consider this one as B1 and this one as B2, the change in flux I can write that one as W2 minus W1. No doubt absolutely in that. But if I write like that, I need to have that into A also. A is area of the coil. But he did not mention that value in the problem. So what we should understand here, since B is proportional to phi or phi is proportional to B, straight away I can write 1 by 5R, that is effective resistance, into, we have to go for change in phi by time. Change in phi linked with the coil. What will be linked with the coil? If n turns are there, the amount of value of B linked with the coil will be NW. So even here also it becomes N times W. So what I can write now? It will now be N times W2 minus W1 over T here. So what you should understand from this? This particular value what he is giving in the problem, probably his intention is to write that one itself as the change in magnetic flux that is observed in the system. So what can we write now? This implies the current I becomes N times W2 minus W1 by 5RT. This is the correct version. Out of the 4 options given, look at the first option first. It is W2 minus W1 by 5R into N into T. 5R N T totally in the denominator. And second option is given N times W2 minus W1 divided by 5RT. Third option is minus of W2 minus W1 by 5RNT. And fourth option minus N into W2 minus W1 by RNT. One thing you should understand out of the 4 options, the moment you look at the options, you can cut third and fourth options right away. Reason, you can better understand. When R is the resistance of the coil given, 4R is the resistance of the galvanometer given. When both are connected in series, effective resistance should become 5R. That is the first observation what we should have. Then what you can understand, in your correct option out of the 4 given, there should be resistance as 5R. There are only 2 options in which we are finding 5R terminology. So either A or B should be correct. C and D are outrightly wrong. Forget. Out of the 2, which is the right one? Just adopt the formula and finalize. So this now is coinciding with the second option given over there as B. So you can directly understand the correct answer for this one according to the options given is B itself. So this is problem number 4 what we have. Look at the next problem. The flux linked with a coil at any instant t is given by phi is equal to 10t square minus 50t plus 250. what is the induced EMF at t is equal to 3 seconds. Flux linked with a coil at any instant t is given by the relation phi is equal to 10t square. He has given an equation over there, 10t square minus 50t plus 250. Now this equation when has been given, we know very well the induced EMF will now be the rate of change of magnetic flux in the system. Since it is a coil here, it should now be called rate of change of magnetic flux linked with the coil. But all of you should be very much thorough with the other part of this equation. That is, according to Lenz's law, the EMF should be opposite in direction to the real cause of it. The way in which the flux that is changing quite opposite to its direction, you will be finding the EMF that is generated in the form of induced EMF there. So what we should understand here? Minus d phi by dt. Suppose I have not taken this negative sign, I may be getting a different answer than what is really needed over there. So what we can understand, it is now negative sign, you keep it. D phi by dt now becomes 20t minus 50. Very simple concept, there is nothing in that. Accepting this negative sign's importance in this, there is nothing else that one should remember. Now when time given over here is 3 seconds, then you can directly write E is equal to minus of 60 minus 50, which now becomes minus 10 volt. If you look at those options given, first option is minus 190 volt. Second option is given minus 10 volt. Third option is given plus 10 volt. And fourth option is given plus 190 volt. So by this time, all of you might have understood what is the point that is to be taken care of. That is this negative sign. Suppose I have not taken this negative sign, I'll definitely get 10 volt there, which is tallied with third option. But in reality, third option is not the correct answer. The correct answer is the second option over here. So answer for this one is B. So one should understand, whenever we write EMF as rate of change of magnetic flux, we should write with its negative sign as well. Application of Lenz formula also is to be taken into consideration. Otherwise, you get magnitude may be same, but with a different sign. That is the point. So the answer for this particular question is B, which is minus 10 volt. A simple and a basic equation and basic method of doing the problem, but for that negative sign, no other special importance that we have as far as this particular problem that is concerned. So this is problem number 5 what we have in this order. See, one more problem here is awaiting based on motional EMF again. These are very commonly asked models. Problem number 6, let me read it out. A metal conductor of length 1 meter rotates vertically about one of its ends at an angular velocity 5 radian per second. He has mentioned very clearly there, omega is given as 1 radian per second. That's what has been given. That is 5 radian per second. And length is given 1 meter. These are the two values which have been provided to us first. What next? If the horizontal component of Earth's magnetic field is 2 into 10 power minus 5 Tesla, then the EMF developed between the two ends of the conductor is how much? So horizontal component is given something like 2 into 10 power minus 5 Tesla. This is BH. Now what is the concept? First of all, you try to understand. There is a rod like this, a uniform metal conductor, which is fixed at one end. With respect to this particular fixed point, it is now rotating in the vertical plane like this. That's what actually he is mentioning. Then think it over. When it is just rotating like this, the horizontal magnetic field is there of Earth. The lines of force are going to be in this direction. Then this particular rod cuts those lines of force. That in the sense what happens? There is a possibility of having rate of change of magnetic flux. That rate of change of magnetic flux will now produce or induce an EMF across the ends of this particular conductor. So that is what he is asking you to calculate. What is induced EMF developed between the two ends of the conductor? That is the concept. So it is with respect to this particular fixed point, the system is now rotating in a circular manner like that. In the vertical circle, of course, it is rotating. That's what one has to understand from this. The options are given this way. First option is 5 microvolt. Second option is given 50 microvolt. And option 3 is given 5 millivolt. And option 4 is given 50 millivolt. So the correct option actually out of the 4 is the second one, which is 50 microvolt over here in this particular problem. So let us first of all check what is the general formula for E. No doubt d phi by dt. But we can rewrite the same thing this way, that in other words, I can take this one as BA by T. Phi being B into A, BA cos theta. That is actually the concept. But what will be the value of A when it is just making vertical rotation like? You can certainly understand that A as B by T, you write it as it is, half base into height like. It's a sector like we people have to go for. That of course you can understand like L square theta. So every one of you can understand this one half L square theta. But what is this theta over T? Nothing other than angular displacement by time, which is called angular frequency or angular velocity in this particular case. So you can directly write the same equation this way, half BL square omega. That is the magnitude of that induced EMF which is observed across the ends of that conductor, which is with respect to one fixed end is rotating now in a vertical plane like. So all the values are mentioned over here, right? Half. The value of BH is given 2 into 10 power minus 5. L square, of course, whether you write 1 square or not, hardly that matters. What is the other value of omega? It's now 5. Now in fact, you can cut these two off. Straight away you will be getting 5 into 10 power minus 5 volt. Okay, you can even rewrite the same thing this way, 50 microvolt. So the point here you should understand is, this is the formula for area of that particular body which is rotating in the vertical plane, like that's the point. So if you take that, 50 microvolt is now tallied with the second option over there. So we can write directly the answer for this one as B. So even this also is based on motional EMF only, but the body is not moving linearly there. It's rotating with respect to a fixed axis inside that magnetic field. Once again you should understand, if at all the body rotates in a direction parallel to the magnetic field, then there will be no induced EMF. It should definitely be perpendicular, then only maximum induced EMF is going to be induced. So that is the concept one should understand from this problem number 6. So the correct answer for this one is 50 microvolt, which is coinciding with or tallying with the second option given in the problem. Let us check out the next number. That's problem number 7, which once again is a small application on transient currents. Like he is just giving us the question based on growth of current in an LR circuit. So what is the question given? Let us check. A coil of inductance 300 millihenry and resistance 2 ohm is connected to a source of voltage 2 volt. Now his question is, the current reaches half of its steady state value in what time? How much time it takes to reach half of its steady state value? Half of its steady state value means what after all? Half of the peak value. That's what he is actually talking about. He is giving us 4 options once again. The very first option is 0.05 seconds. Second option is 0.1 second. Third option is 0.15 second. And option number 4 is 0.03 seconds. As such, correct option for this one is nearly 0.1 seconds. So it's the second option. What are the values he has given? First, let me write the data over here so that you can have the idea how to just substitute those values in the formula required. So he has given you the value of L first. It is a 300 millihenry like he gave. That is inductance value he has mentioned. And the resistance is given directly as 2 ohm. You can directly understand that. The current reaches half of its steady state in what time? And of course, potential difference across the system also is given as 2 volt for us. That is the one. Now, first and foremost, this is a concept of L and R connected across a cell like this. This is being R, this is being L, this of course is the applied voltage. Then current grows to the maximum possible value there. That is what is of course called instantaneous value at that particular time of instant or instant of time. If I take that one, I becomes I naught into 1 minus e power minus t by tau. That is what actually is the value. Out of it we know I naught now becomes peak value. And of course the value of small t is how much is the question he is asking. And tau is no doubt a time constant of LR circuit. So what is going to be this time constant first of all? Tau is known to you all as L by R. So you can now write this one 300 over 2, which is 150 into 10 power minus 3, that you can write 0.15 second. And of course the value of I is given over here as I naught by 2. He said the current reaches half of its steady value, steady state value. So you know this I is as I naught by 2, that you substitute it over here now, I naught getting cancelled, half is equal to 1 minus e power minus t by 0.15 we'll get. In other words, you can rewrite the same this way, e power minus t by 0.15, that is equivalent to 1 by 2. So you can even rewrite the same this way, e power t by 0.15, right, is equal to 2. What for you can better understand is 5 power minus t by 0.15 can be written 1 by e power t by 0.15. So denominators I have equated, nothing special there. This now becomes log of 2 to the base e is t by 0.15. And of course our required value is small t. Therefore, small t is equal to 0.15 into log of 2 to the base a. In fact, every one of you know this value thoroughly, 0.693. So straight away if you put that value and multiply these two, you will be getting nearly 0.1 second. So this value of log of 2 to the base e is 0.693. Writing that value, multiply these two, your answer will be very, very close to 0.1 out of the 4 options given. Which is the best suitable answer we have to pick up. 0.1 nearly I said, first option is given 0.05, nowhere nearer. 0.15, it's more. Third option. Fourth option 0.03, it's too less a value than this. So the second option is going to be the correct answer out of the 4. So only thing you need to understand is which is the nearby answer, nearly 0.1. Therefore, we can directly go ahead this way, the answer for this one as B, that is the case. So only thing you should understand from this entire concept is, it's a problem based on transient currents. And particularly this problem has been made based on growth of current in an LR circuit. So how the growth that is taken up here, and this is the formula we have to go for. Out of that we need to know what is the value of time constant over here, that's L by R. Directly you can estimate the other things. It's not a difficult task for you to get. So second option is the right option for problem number 7 what we have here.